Hey everybody, Mr. Field here, and welcome to our coordinates, lines, and slope review. In order to be successful in the next unit, which is coordinate geometry, it's really important to first understand the coordinate plane, what it's comprised of, what it's made up of, also linear equations and slope. So with that said, let's just jump right in. So part one says clearly label the x and y axis. Well, the coordinate plane is created with the intersection of the x and then y-axis. So x controls the horizontal direction, or left and right, and then y is the vertical direction, or up and down. And the point where they meet in the middle, and I'm actually going to say part three already, is called the origin, which essentially means the beginning. That is the coordinate location of 0, 0. It's essentially your starting place. It's telling you we haven't gone anywhere yet. Now, just a quick coordinate review. Remember, every coordinate has an x and y value. X tells you where you went starting at the origin, left or right, and then y tells you up or down. Obviously, if we're hanging out at 0, 0, we didn't go anywhere just yet. So we have the x-axis, the y-axis. It looks like we check off 3, we check off 1. Now we're going to label each quadrant. So it's kind of strange, but quadrant 1 starts in the top right corner, and then we actually go counterclockwise. So 2 is to the left, quadrant 3, and of course quadrant 4. Now, another important thing to note, quadrant 1 is where we keep it real, all right? That's where all our real numbers exist. So when you're talking about a real life problem, typically you're hanging out in the first quadrant. Why? Because, well, we don't always experience negatives in the real world. So typically, if you're talking about a real life situation like length or width, you're going to be hanging out in the first quadrant because you can't have a negative length or width. Then, of course, it wants us to plot some points. So let's go ahead and do that. So again, every coordinate has an x and y value. So it's x first, then y. And we always start at the origin. That's the beginning. So -2, 0 means we're going left 2, up and down none. Because the x value is negative, it tells us to go left. If it's positive, it tells us to go right. So in this case, left 2, up and down none. I can label that point A. B, we have 5, -6. We're going to go right, starting from the origin, because it's a positive 5. 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6. So point B should be right about there. Ooh, fix that B up. Then we have point C. So I see positive, positive. So I'm thinking x value is positive, so right 4, y value is positive, up 3. So starting at the origin, we go right 4, up 1, 2, 3. And that should be point C. Last but not least, -10, 10. So that's telling me to go left 10, down, -10, -10. Gotta be careful. Attention to detail is important, folks. So -10 means left 10, down 10. So we should be hanging out right there, and that would be point D. So hopefully you're feeling a little bit better about the quadrants, the coordinate plane itself, what the origin means, how to plot points, and of course the x and y axis. We don't want to mix those up. So since we've checked those boxes, let's keep cruising. So graphing lines, all right? So first and foremost, we have this thing called slope-intercept form. Y equals mx plus b, where m is the slope, right? And the slope has several different names. It's also known as the rate of change. Essentially, the slope is how you're moving, how the line is behaving. Is it increasing, decreasing? Is it going up 2, right 1? I don't know. Let's find out. So when we're talking slope-intercept form, it's called slope-intercept form because you can clearly see the slope, and then the b value, that's the y-intercept, which is where the line crosses the y-axis, which would be this one right here. So when you're graphing lines, there's lots of ways to do it. Old school version, you might have created an XY table, and then maybe you started plugging in numbers. So you'd say like 0, 1, 2, meaning we're going to substitute in for the first one, 0 in for x into the equation, and it would spit out the y value, and then we could plot those coordinates. So if I do 2/3 times 0, I get 0. So it looks like we're starting at 0, 0. If I plug in 1, well, I would get 2/3 times 1 is just 1. So we'd have 1, 2/3, which is kind of tough to graph, actually. So I'm glad I did this. We have to go right 1, up not even a full 1, 2 out of 3. So it'd be something like that. So you can, of course, always go back to this method. However, it's a little bit faster if we graph it this way. So just a quick review. First and foremost, when we're thinking slope-intercept form, to me it looks like the slope of this line is 2/3. And notice it doesn't have, there's nothing being added or subtracted on the end of this equation. There is no b value, so to speak. So we always assume it's 0. So when I look at this, I like to think that B is where you begin, M is how you move. That's how I like to think about slope. So, well, B is where we begin, so plus 0. So we're going to start at 0, where that purple dot is that I'm highlighting over right now. And then we're supposed to move 2 over 3. Now, when we think about this, slope is also considered rate of change or rise over run. Well, Y controls up and down. That's the rise of rise over run. X controls left and right. So that's the run. So we're running left and right, we're rising up and down. So if we follow that pattern, to me, since 2 is positive and it's represented by a y value, that's the rise, and that means from this point, the first point where we begin, we're supposed to go up 1, 2, and then we're supposed to run positive 3. Now, since x controls left and right, and 3 is positive, we're going to go right 3. So we're going to go up 1, 2, right 1, 2, 3. Boom. Then we can continue that process up 1, 2, right 1, 2, 3. Boom. Now, keep in mind, we could technically also go in reverse. We could do the exact opposite. The opposite of going up 2 would be down 1, 2. The opposite of going right 3 would be left 1, 2, 3. And in general, down 2, left 1, 2, 3. The more points you have, the more accurate your line will be. So that's graphing using slope intercept form. And notice this one had no y-intercept, meaning it simply starts really, well, it's not listed. Technically, it does have a y-intercept, but notice y equals 2/3 x plus nothing. When there's nothing there, you assume it's 0. So it's kind of a sneaky one. So I wanted to make sure I covered it. And then, of course, back in Algebra 1, probably talked about how to describe the behavior of the line, right? Obviously, the slope is the best way to do it. Notice it's positive 2/3, so you'd say it's increasing. Then you could, of course, talk about how it's increasing. Is it increasing moderately or rapidly? I'd say this is relatively moderately, kind of in the middle. Again, the larger the slope, the bigger the number, right? The faster the line will increase. All right, so let's keep moving. Try a couple more. Case 2. So this is a special one. Sometimes you'll see an x equals or a y equals when you're graphing lines. It's kind of sneaky. Again, we're used to seeing y equals mx plus b, slope intercept form. However, sometimes they throw you a curveball like this. So when you're seeing something like x equals -4, what that's telling me is I'm going to go left 1, 2, 3, 4. And that would be a vertical line at x equals -4. So it's kind of something that you have to memorize, I suppose. So again, the x value, the only possible value for x in this line is -4. So all of the points have to exist at x is -4. So it ends up being a vertical line at -4. So sometimes they don't give you slope intercept form. The opposite of that, y equals 6, well, that tells me I have to go up because it's positive. 1, 2, 3, 4, 5, 6. And all of the values in this equation have to exist at y equals 6. So it doesn't matter what you plug in for x. If I plug in 2, I get 6. If I plug in 4, I get 6. The only possible answer is 6. So that would be a horizontal line. Considering having a flat slope, and actually before I forget, just going back, this would be considered having an undefined slope in this case. So let's keep going. Here's a more normal situation that we have going on. And I know with my classes, with my students, I always like them to take a look at the equation itself before you even start. Again, M is how we move, B is where we begin. So before we start graphing, I would hope you could look at that equation and realize that this is going to be an increasing line, right? It's going to be going up as we move from left to right. How do I know that? Because the slope is positive. It's a positive 3/5. I would also hope that you would also know, if I was going to compare this to a line like y equals 3x minus 2, notice they're starting at the same place, -2, but one of them is going to be increasing a lot faster. Hopefully you realize it would be 3, because 3 is a larger number than 3/5. We know that this line on the right, the purple one, would be a lot steeper, whereas the one on the left would be a little bit flatter. So before you actually even start graphing, you should be able to look at the equation and tell us a little bit about it. That way, when you actually graph it, hopefully everything lines up, pun intended, and makes sense, right? If you have, for instance, a negative in front of your 3 there, that coefficient, the negative slope, it should be decreasing. It should be going down from left to right. And if you end up graphing a line that's going up, well, hopefully common sense would take over and you would go, uh-oh, something's wrong. So let's actually graph this bad boy. So I'm thinking we have a 3/5 slope minus 2. Remember, b is where you begin. So we're beginning down 2. Then, of course, we're going to go positive 3, right? Rise over run. We know y is the rise because it controls the vertical direction up and down. X is the run. Since they're both positive, so I'm thinking y controls up for positive, down for negative. So we're going to go up 3. And then x controls left and right, right 5. Up 3, right 5. Up 1, 2, 3, right 1, 2, 3, 4, 5. Boom. Of course, we can continue that process up 1, 2, 3, right 1, 2, 3, 4, 5. Kind of run out of room here. And of course, we could go in reverse, exact reverse. The opposite of going up 3, right 5 is down 1, 2, 3, left 1, 2, 3, 4, 5. And of course, we can draw our line, arrows on the end indicating it goes on forever and ever. And then there she is. And hopefully it adds up again. It makes sense, right? We have a positive slope. Notice it's increasing. Typically, when you see fractional slopes, most of the time you're going to notice it's a moderately increasing or decreasing. But in this case, it should be increasing because it's a positive line. Notice if I had for instance, that y equals 3, x minus 2, it would be a lot steeper. It would probably look more like this, going really, really steep. All right. So that being said, based on the line, we could also find what I like to call critical points or critical values. These are typically and commonly referred to as x and y intercepts. If there was a context part, if we were graphing this line to say like to represent your bank account, these values, the y-intercept, which is right there, which I would say is at 0, -2. I went left and right none, down 2. Or the x-intercept, which looks to be right here, which I would say is at 3, 0. They would have actual meaning in the context of the real world problem. So it's really important that you can point those critical values or critical points out once you have graphed it. All right, let's keep moving along because I've got a lot for you. Keep in mind y equals mx plus b. That's not the only form that is available to us. You might have also talked about, and I'm sure you did, standard form, ax plus by equals c. Now, it looks scary. And some people might deal with this in a different way than I do. But me personally, I know I can always convert to slope-intercept form. I can make it look like this. Why or how? By getting y by itself. So what I would do is subtract 3x from both sides. These would cancel, giving me -4y equals, notice 12 minus 3x, they're not like terms, so I cannot combine them. Now you could write it like this. But typically in slope-intercept form, that mx part, right, the x goes first. So as long as I still have a minus 3x, notice that's a positive 12, we're still in business. And then last but not least, y is the total itself. We divide everything on the left by -4, better divide everything on the right by -4. So we end up with y equals negative or negative, double negative becomes positive, 3/4 x, and then 12 divided by -4 should be -3. And now we're in business. Now we know that we begin at -3, so down 1, 2, 3, boom. And we're going to go up 3, right 4. Up 1, 2, 3, right 1, 2, 3, 4. Of course, I go to down 1, 2, 3, left 1, 2, 3, 4. And here's our line. Notice again, it's a positive slope. It's increasing. We can clearly see our x-intercept here at 4, 0, our y-intercept at 0, -3. We know our critical values. So if you ever encounter standard form, I typically like to just convert to slope-intercept, meaning get y by itself and then graph like you have been for quite a long time. All right, a few more examples. We're going to skip domain and range, not super excited about that. We kind of already covered this, but if you were going to, sometimes they give you the line. They're kind of being bad here. They really should have arrows on the ends. So it's just like clearly label the x and y intercepts. I like this one because, well, there's a clear y-intercept right there at the point 0, up 4, left and right none, up 4. But it's not clear because it looks like this line's going to continue off the graph. It's actually not clear. At some point, it will cross the x-axis, maybe at about 1, 2, 3, maybe it's at like 13 or 14, 0. That's why I like Desmos, the graphing app is awesome, the online app. So sometimes you'll see us use that, but it doesn't appear like we have enough information to accurately guess the x-intercept. So I'm just going to go ahead and leave that alone. So you do encounter situations like that where you can't really see it. But let's go on the 2. Describe the behavior. What that means is it increasing or decreasing? And hopefully you would agree this is a decreasing line. And it also helps sometimes to find the slope. So if I pick a random point, and that's a good one, looks like I go down 1, right 1, 2, 3. Let's see if that pattern continues. Down 1, right 1, 2, 3. So it looks like this is a slope, right, of down 1, right 3, or -1/3. That should probably be our slope. So the behavior would be that it's decreasing from left to right. And I'd say it's decreasing pretty slowly or moderately. I wouldn't say it's a rapid decrease. Like, for instance, if any skiers out there, if you were on this slope, right, and you were going to ski down this slope, I wouldn't say it's very steep, so you probably wouldn't be going too fast. This is more like a bunny hill, right? Now, 4 is important. What's the equation of the line in slope-intercept form? So given the graph, I know we have y equals mx plus b. So far, we have the slope, right? We picked any random point. I could have started way over here. But again, we want to pick points just to throw it out there. It wouldn't be a good idea to maybe pick this point. Because as you can see, it's not perfectly crossing at one of these intersections along the grid lines. And then what that means is, we're going to end up with not the prettiest numbers, right? We want to pick whole numbers. And again, if I started here, down 1, right, 1, 2, 3, ding, ding, ding. So it looks like it does follow that same pattern. So as far as my equation goes, so far I have y equals negative 1/3 x plus b, which is the y-intercept, which thankfully we already know. It's up at 1, 2, 3, 4. So instead of plus b, we could just say plus 4. And we're done. All right, so that's how you find the equation of a line given a graph. And of course, you should be able to describe the behavior, find those critical values, x, y intercepts, etc. A little bit harder now, write the equation of the line. Notice it's not giving us a graph. We don't always have that tool. Keep in mind, you could always graph it, plot the points, right? And then connect the dots and see what it looks like. You can always have that option. However, well, let's see what we can do algebraically. So when it says write the equation line, you have plenty of options. You could do slope-intercept form, which is the most popular. There's also this thing called point slope, which you could use, or of course you could always use standard form. But me personally, I'm a big slope-intercept form fan. So I'm going to take this information, y equals mx plus b, and these 2 points, which by the way we have x comma y, and really I'm going to say x1, y1, x2, y2, which is a fancy way of organizing and saying, hey, first x I see, first y I see. Second x I see, second y I see. And we're going to find the equation of this line mathematically using algebra. So the slope formula is x2 minus x1 over y2 is y1. So all we have to do is substitute in our values. So I'm thinking we have 1 minus 2, this one minus this one, and we go back y2. Wow, okay, let's go back. I guess I need some coffee, folks. Excuse me, it's supposed to be rise over 1. y2 minus y1, something seemed off here, and I'm glad I caught myself, over x2 minus x1. Pardon me, everybody. So we should be doing y2 over minus y1, which again, I did write when I wrote it out, 1 minus 2. And then we should be doing x2 minus x1. Oh, and I'm messing up again. Woo! Hold on. 1 minus 5, excuse me. It should be y2 minus y1, and then x2 minus x1. So up top, 1 minus 5 is negative 4. On the bottom, 0 minus 2 is negative 2. And negative 4 divided by negative 2, double negative becomes positive. We have a slope of 2, or you could argue it's 2 over 1, which would help us graph it. So far, pardon the issues, my friends. Too early for me, I suppose. We have y equals 2x plus something, right? So we have to find that y-intercept. We have the slope. We're halfway done. So typically, when you're looking for the y-intercept, you pick a random point, and you're going to substitute it in for x and y. So that's what we're going to do. One of these, this one, I think looks easier. Zeros and ones are really easy to deal with. Not that 2 and 5 would be bad. You could have chosen 2 and 5. But in this case, I want to pick the easier one. So for x, I'm going to substitute in 0. And for y, I'm going to substitute in 1. So we get 1 equals 2 times 0 plus b. And b is what we're looking for, so we're going to try and get b by itself. So 1 equals, well, 2 times 0 is just 0 plus b, which means 1 equals b, or long story short, b is 1. So we're happy. We know our equation should be y equals 2x plus 1. Boom. So that's how you find the equation of the line given 2 random points. And you can do the same thing from a graph as well by picking 2 random points. So I don't want to harp on that too much. We're going to keep cruising. There's a whole bunch of the same type of problem. So let's check this one out. We already did this before, so I'm going to keep moving. Slope-intercept form, we talked about that. So pardon me, friends. I got a lot of problems on here I want to talk about. Let's see. So the next thing, and probably the most important, so finding x and y intercepts. This is another skill. Of course, you could graph this, right? Option 1 is you could convert this to slope-intercept form. by getting y by itself. Then you could graph it, and then you could say, hey, here's physically where the x and y intercepts. Here's where it crosses the x-axis. Here's where it crosses the y-axis. But the skill that you really need to know is how to do this algebraically as well. So let's say I'm looking for an x-intercept. And notice this is given in standard form, ax plus by equals c. So, oops, capital. And when you're looking for an x-intercept, right, if we really think about it graphically, x-intercepts are all along, it's where the line crosses the x-axis. So any of these points, any of these green dots I just drew, is always going to follow this pattern. Some number, comma 0, 2, comma 0, 3, comma 0, negative 2, comma 0. Notice it's always going to be comma 0. Why? Because the x value controls left and right. Y is the height. And if you're along the x-axis, well, you didn't go up or down. So the y value will always be 0. So that's why when we're looking for an x-intercept, we're just going to take the equation that we're given, and we're going to plug in 0, or a height of 0 for y. So here we go. 4 times, oops, pardon, 4 times x plus 5 times 0 equals 20. We're going to get x by itself. Well, that gets us 4x equals 20, because 5 times 0 is 0, so it cancels out. To get x by itself, we divide by 4. It looks like the x-intercept would be at 5, comma 0. All right, let's keep going. So the opposite of that is, hey, x-intercept, we know y is 0, so we're going to plug in 0 for the height. Well, if we're looking for a y-intercept, we just do the opposite, the exact opposite. So I'm going to plug in 0 for x into the same equation and see what we get. So I'm thinking we're going to have 4 times 0 plus 5y is 20. Well, 4 times 0 is, well, see you later, it's just 0. So we get 5y equals 20. Divide by 5. And looks like y-intercept should be 4. Now, as a coordinate, right, we plugged in 0 for x, and it spat out a y value of 4. So it would be 0, comma 4. And technically, once you have these two, you only need 2 points to graph a line. So you can plot the point 5, 0, plot the point 0, 4, draw a line connecting the dots, arrows on the end, and you could graph that way as well. But it's important you know how to find x and y intercepts algebraically. So let's move on to the last part that we really care about. Systems of equations, parallel lines, perpendicular, that's important too. So sometimes you're asked to graph more than one line, and that's what we call a system of equations. It's at least 2 lines, could be more. First and foremost, just looking at these, I'm going to look at example B to start. One of the things I hope you could do, again, is describe the behavior of these 2 lines. Hopefully you would agree the first line here, negative 1/3 x minus 1, is a negative slope. It's going to be decreasing, whereas the second one is a positive slope. So I know for sure they're going to intersect. They're going to cross each other. They have to. There's no way that they won't. Since one is going down from left to right, one is going up, and since lines are infinite, they go on forever, they're going to have to cross each other. So with a system, you're typically looking for the solution to a system, which would be the point of intersection. Keep in mind, not all lines cross, but this one definitely, these two, pardon, definitely will. So let's graph real quick. So let's graph the first one. We're starting down 1, the y-intercept, and then we're going to go, and here's an interesting thing. Sometimes you see a slope, and you see the negative kind of hanging out in front. It's really important that you choose wisely here. Typically, you just take the negative and you put it up top, but it doesn't really matter. When you see the negative out front, you typically put it up top with the y value, with the rise part, but you don't have to. The only thing you can't do is this. You can't distribute the negative to both the top and bottom of the fraction, because that becomes double negative, which then becomes positive 1/3, and then you're going to end up graphing the wrong line. So it doesn't really matter if I'm going down 1, right 3, or if I'm going up 1, left 3, you're still graphing the same line. So we're going to start at -1, and I'm going to decide to go down 1, right 1, 2, 3. Down 1, right 1, 2, 3. And I could go up 1, left 1, 2, 3. Notice it's the same thing. Up 1, left 1, 2, 3. And of course, we can graph that line. Arrows on the ends. Boom. Now graphing the other one, we're going to start at -4. That's our beginning move, right? Our y-intercept. Down 1, 2, 3, 4. And then we're going to go up to right 3. These are both positive. Up 1, 2, right 1, 2, 3. Ding, ding, ding. Up 1, 2, right 1, 2, 3. And I said ding, ding, ding because the solution to a system is where the lines intersect. So in this case, they do have a solution. Looks like they cross at right 1, 2, 3, down 1, 2. So that would be the solution to that system of equations. If we were to plug in x and y, right, 3 and -2, into either of these equations, it would be a solution, meaning it would balance the equations. You would get the left side equal to the right side. So that's systems. However, not all systems are going, not all lines, are going across. So the example we just looked at, notice this is an example where there's one solution. These two lines will intersect, but we also have these things called parallel lines, which means they're never going to intersect. Why? Because they're behaving the same way. They have the same slope. Notice up 1, right 1, up 1, right 1. And this one also up 1, right 1, up 1, right 1. So long story short, they start at different places. Notice this line here starts up at 1. This line here starts down 1. Since they have the same slope and they're behaving the same way, they're never going to intersect, and they'll always remain the same distance apart. It's another part of parallel people tend to forget throughout infinity. So sometimes there is no solution, right? These lines will not cross, and we have these parallel lines. That's the situation where you have no solution. And of course, we have infinitely many solutions. Sometimes it's strange, but they'll give you the same line graphed on top of itself, which means not only do they meet once, they meet an infinite amount of times. So I would hope you could look at these equations and tell me which one's which. So number one is pretty easy because thankfully they're in the same form. Y equals mx plus b, y equals mx plus b. And here's the thing, if they have the same slope, but they start at different places, like this one, down 3, this one starts up 1, we know that these two lines are going to be parallel, which means there would be no solution. They're never going to intersect. When I look at number 2, that's a little sneaky because notice we have one in slope-intercept form, one in standard form, that ax plus by equals c. So we would have to add 3x to the other side to realize y equals 3x plus 1. Well, notice y equals 3x plus 1, y equals 3x plus 1. They're the same equation. So we would have infinitely many solutions. And then finally, the one we didn't talk about yet is not only do they meet, it's almost essentially the opposite of parallel. It is perpendicular, meaning not only do they cross nice and pretty, and they make a right angle. We know that these are perpendicular if they have opposite reciprocal slopes. Opposite meaning one's positive, one's negative. Reciprocal meaning the flip of each other. Notice the top slope is positive 3 over positive 4. The next one's negative 4 over 3, right? So notice they flipped 3, 4, 4 over 3. And one's positive, one's negative. These would be perpendicular, meaning not only do they intersect, they're going to intersect and form a right angle. So hopefully this review was helpful of parallel, perpendicular, graphing, lines, finding x-intercepts, and critical values. So please move on to the next activity, and thanks for watching.